Hello, this video is second part of Secrets of Imbalance series. In this video, I would like to explain the relation between heavy spot position and vibrations in acceleration, velocity and displacement. Understanding of that will help you in balancing jobs. In the beginning, I would like explain some words which I will use in video. Their meanings must be clear for video understanding. The standard sine signal is on the picture. It can be acceleration, velocity or displacement. It is not important for next explanations. I can draw the red point in any time of signal. In each its time, I can describe two things. It is the sign of position and the direction of movement. The position is positive because the value in graph is greater than 0. The movement is positive because the value change is upward. By math words, the derivation is greater than 0. The position is negative because the value in graph is less than 0. The movement is negative because the value change is downward. By math words, the derivation is less than 0. The position is positive because the value in graph is greater than 0. The movement is negative because the value change is downward. The derivation is less than 0. The position is negative because the value in graph is less than 0. The movement is positive because the value change is upward. The derivation is greater than 0. This position we call 0 or the middle or resting position. The movement is positive because the value change is upward. The derivation is greater than 0. The position is positive because the value in graph is greater than 0. The movement is stopped. It is 0 movement. It is the moment when the upward movement changes to downward. The derivation is 0. It is again the 0 or the middle or resting position. The movement is negative because the value change is downward. The derivation is less than 0. The position is negative because the value in graph is less than 0. The movement is stopped. It is 0 movement. It is the moment when the downward movement changes to upward. The derivation is 0. As I promised on the end of part 1, in this part 2 we will measure with acceleration sensor. This is again the real electric fan and the accelerometer. The tachosensor is used for measurement triggering. The red ray shines here on rotor. We use the reflective tape for tachosensor. When the tape is going through the red ray point, the light is reflected and tachosensor creates the voltage pulse. This pulse triggers or starts the measurement. In next explanations, we use the ADAS VA5 analyzer. We measure the acceleration signal and the analyzer recalculates it to velocity and displacement signals. We also use the APS measurement. It gives us the amplitude and phase on speed frequency. The first measurement displays the velocity and displacement time signal. You see the millimeters per second and micrometers units. Here are amplitudes and phases on speed frequency for velocity and displacement. Look at the displacement signal below. I marked the lowest position. It is the negative maximum position. Look at the velocity signal in the same time. The value is 0. It means no moving, and it is correct. In negative maximum, the moving must stop, because the moving direction must be changed from the downward to upward. From this point, the upward moving begins. It is the positive moving. It means the velocity must be positive too. And it is. This is the positive area of graph. Below you can see the yellow time interval in displacement. A positive movement takes place in this interval. It means the upward movement from negative maximum to positive maximum. Now look at the velocity graph above. Look at the yellow time interval. The velocity is positive in this interval. If the movement is in positive direction, then the velocity must have positive values. Look at this point in displacement. This is the zero displacement point. It is just in the middle between negative maximum and positive maximum. Look at this point in velocity. This is the positive maximum of velocity. It is logical. When the movement passes through the middle point, it has the highest velocity. It increased velocity up to this point. It means it accelerated. From this point, it must decrease the velocity. It means to brake. Why? It is clear. It must stop in this time. The movement must change the direction in this time. It means the velocity must be 0 again. In this interval, a downward movement takes place. The velocity is negative. Try to explain displacement and velocity in this interval yourself. We have described one signal period or one rotation, if you wish. This process is repeated again and again. And the important question: how to find the heavy spot position from velocity measurements? We know that the displacement phase value exactly tells us where the heavy spot is. In this example, the phase is 0 degrees. It means the heavy spot is in the same position as the reflective tape. The velocity phase is 90 degrees. It is clear that we must subtract the 90 degrees from velocity phase, and this phase is the angle of heavy spot position. When we subtract 90 degrees, we are in the same situation like with displacement phase value. Before I begin talk about acceleration, I should tell you some words about force and spring. The motor with flexible foundation is on the picture. It is mounted on springs. The motor does not run now. It is in resting position or 0 position. I apply force upward, for example, by the crane. The springs stretch and makes the opposing force. The force magnitude is proportional to change of spring length. It means bigger stretch makes bigger opposing force. When the plus force made by crane disappears, the spring force minus F returns motor back to the resting position. The same process happens when the spring is compressed. Again, bigger compression makes bigger string opposing force. Now we apply the rigid foundation. Springs are removed and bolts are used. The question is, has anything changed? Answer is no. The bolt is also spring, but much stiffer. This is the similar example. We have the rotor, which is not rotate. It is in resting position. It can move just in vertical direction. As in last example, I can stretch the spring or compress the spring. When the force disappears, the springs returns back to resting position. Now the rotor is running. The heavy spot makes the centrifugal force. At some points the force is big and stretches or compresses the spring. At other points the spring opposing force is bigger and returns rotor back to the resting position. Our rotor can move just in vertical direction. It means just vertical part of centrifugal force is used. Now we a little understand what it is the force. It is pulling or pushing. The basic physical formula tells us that the force is equal to the mass multiplied by the acceleration. The mass is the constant. It means that the acceleration is directly proportional to the force. It means when we speak about force, we speak about the acceleration. Let's imagine some point. It has some weight. It means the mass is greater than 0. The point stands still. Its velocity is 0. We should use the word speed in this example, but it could be confusing. I will use the velocity word. Now we apply the force. We know that we can say we apply the acceleration. It has the same meaning. For example, the acceleration is equal 10 meters per second square. We can use better words. It is 10 meters per second. It means that the velocity increases by 10 meters per second every second. After 1 second, we get 10 meters per second. After 2 seconds, we get 20 meters per second. After 3 seconds, we get 30 meters per second. We began to apply the acceleration when velocity was 0. But it was not necessary. For example, velocity could be 50 meters per second. After the next 1 second, we get 60 meters per second. After 2 seconds, we get 70 meters per second. And after 3 seconds, we get 80 meters per second. And now I ask you for attention. The velocity could be negative in time 0. It means the point was moved to negative direction. For example, velocity was minus 20 meters per second. We applied the same positive acceleration as last time. After 1 second, we get minus 10 meters per second. After 2 seconds, we get 0 meters per second, and after 3 seconds, we get plus 10 meters per second. The important thing to understand is this. When the opposite acceleration is used, then it decreases the velocity. Now, please look at the acceleration time signal and the velocity signal. The acceleration signal is a little distorted. The electric fan which we used has very low mass. It means there are more influences, like for example the table under the fan, which is lightweight and vibrates also a little. Let's begin at this point A. The velocity has reached a negative maximum. The acceleration is 0. Why? Before this time, the negative velocity increased. It means the negative acceleration was applied. From this time, negative velocity decreases. It means the positive acceleration is applied. The acceleration changes from negative to positive. It is clear that must be 0 in the time of change. In this time interval, the velocity is still negative, but the acceleration is positive. It means it decreases the negative velocity. The velocity is equal 0 in point B. In this point, the acceleration has reached a positive maximum. From this point, it will decrease. It must, because in point C, the velocity changes the positive increasing to positive decreasing. The acceleration must decrease from point B because must be 0 in point C. The process in interval from point C to point D is opposite. The velocity is decreasing from positive maximum to negative maximum. The applied acceleration is negative. It must decrease velocity. And what about the phase and heavy spot position? The velocity phase is 90 degrees. We know that we must subtract the 90 degrees from velocity phase to get the displacement phase, which is the angle of heavy spot position. Now we can see that next 90 degrees is added in acceleration phase. So we must subtract 180 degrees to get the displacement phase, which is the angle of heavy spot position. The last example contains acceleration and displacement time signal. It should be easy to understand it already. What is happening in point A? The rotor movement just goes through the middle position and rotor goes up. It means the positive velocity has maximum value. After point A, the velocity must decrease. It means the negative acceleration is applied. The negative acceleration has reached the negative maximum value and velocity is 0. The movement has reached the positive maximum. After the point B, the negative acceleration creates the negative velocity and rotor goes down. In point C has the velocity maximum negative value. In interval from point C to point D is the process opposite against the interval from A to C. And here is just the evidence that we must subtract 180 degrees from acceleration phase to get the displacement phase. In all mentioned examples, we keep one rule. The direction of vibration sensor is the same as direction of tacho sensor. It simplified the examples. If both directions would not be the same, then we must add or subtract their angle value from the final phase value. I think that to keep this rule in practice is easy. Please understand well what this rule means. The sensor can be mounted on many places of machine. We do not care where the place is. The direction of sensor is important. In one place, I can mount sensor in several directions. Each direction needs different position of tacho sensor. And now the final revelation. You can tell me, yes, now I can estimate the heavy spot position after the first run in balancing. But what to do with such information? It is very useful. It allows you to mount the trial mass on the opposite side. It means the vibration in trial run should decrease. And it is good. When you mount the trial mass randomly, then the vibration can increase. And it could be dangerous and machine could be seriously damaged, or the control system stops the machine because of high vibration. I am looking forward to your comments. It helps us decide what video to make next time. Thanks for watching.